My favourite way to introduce people to continuous delivery is to describe it as a way of working so that your software is always in a releasable state. But this is very challenging. It's a difficult thing to achieve, and it challenges many of our assumptions about traditional software development. So what does it take to achieve continuous delivery? Hi, my name is Dave Farley of Continuous Delivery. Today we're going to talk about the foundations of continuous delivery. What is continuous delivery, and what sorts of ideas do we need to be considering in order to be able to practice it? I would argue that continuous delivery is the state of the art for software development at the moment. It allows us to create better software faster, and that's what we've been trying to do for decades. The companies that practice continuous delivery make more money and have happier staff and higher staff retention figures than companies that don't. They produce software with orders of magnitude fewer defects, release thousands of times more frequently than more traditional development shops, and these are ideas that have revolutionised the practice of software development and are practiced by some of the household names, the people that we think of as world-class experts in software development. So what ideas power these revolutionary changes, and why does it work? In order to practice software development, there are some essential activities that we can't avoid. We need to be able to analyse the problem that we're working in and understand how we want to make progress in that context. We need to think about the design of the software that we're going to undertake and what kinds of approaches we're going to take to solving the problem that's before us. We need to do the coding, we need to write the tests, we need to deploy things into production. All of these things are kind of essential activities. We've learnt over the years that those are not best practice as separate stages. We need to be doing all of those things continuously. And when we work that way, we can gain significant advantage and much better feedback in our efforts. Instead of finding out months later that our analysis was wrong and our design was bad, we can find out in a matter of hours or days. And that gives us an enormous step up in our ability to make higher quality software and solve problems more efficiently. The first thing to consider is the idea of feedback, of efficient feedback. I would argue that software development is primarily about learning. We are always in a position of trying to understand and deepen our understanding of the problem domain, the technology that we're working on, the design of our system, and trying to improve that. And in order to be great at learning, we need high quality, fast, efficient feedback. Continuous delivery is built on the idea of feedback. It's kind of where we started from, to make that feedback faster and of higher quality to support our development efforts. The next real principle, I think, is strong engineering discipline. This is a disciplined approach to software development. This is not just craft-based. Craft is important, and it's important that we can create things, but this is engineering. This is the application of scientific-style reasoning and applying that kind of thinking to solving problems in software. And that takes a degree of discipline. Now, this isn't hard science. We're not doing Six Sigma statistical analysis of the results all of the time, but we are taking the ideas of evidence seriously, and we are building our software development process on that kind of approach. We also need to reduce the amount of work that we do. If we want to build better software faster, we need the most efficient process to be faster, and we also need to be working with high quality so that the software is better. And we can reduce the amount of work that it takes to achieve both of those things at the same time through automation and process efficiency. This is grounded in the ideas of lean thinking. So continuous delivery is an application of scientific rationalism to solving problems in software, and it's about lean thinking, working efficiently and getting the most impact for the least amount of work. So trying to be smart about the kinds of processes and approaches that we can use to using those sort of things. There's a trick in all of this that allows us to drive some of this change, and this is the idea of cycle time or lead time reduction. And we can use that tool as a driver of change. Cycle time is an interesting idea. Cycle time is the distance between having an idea and getting that idea into the hands of users, and that allowing us to figure out what our users make of those ideas. This is a foundational concept in continuous delivery, and if we start applying this rigorously, how do we work to reduce our cycle time? It allows us to work to optimize our processes, our technologies, and our approaches to the design of our systems to get some of the benefits that we're talking about. Cycle time is deeply important. Here are two different examples of cycle times from projects that I worked on. The first example was for a fairly traditional project where we were doing an order management system for a large bank. And in that example, the bank could not release a single line change into their production systems in less than 103 days. If you've got that kind of cycle time, then essentially you have no feedback. Here is a second example. In this second example, this is a system of 15 to 20 times the complexity of the first system. This was a high performance, low latency financial exchange. This was a serious grown-up system, and the entire enterprise system was was developed and refined using the techniques of continuous delivery. In this approach, we could make any change to our enterprise system and evaluate that to the point at which we had a releasable software artifact and get that result back in 57 minutes. That's dramatic. That is game-changing in our ability to deliver change. If we can make any change and get a definitive answer, is this safe to release or not, in under an hour, that means that we can start being experimental, we can start playing with ideas, we can try different techniques out, different technologies, different design approaches, different solutions for our users. All of these things are enabled by reducing the cycle time, improving the quality and efficiency of the feedback cycles that we can work on. To do that requires deep automation and this kind of lean thinking and scientific rationalism that I was talking about before. The automation is crucial. If we want to be lean, if we want to reduce the amount of work that we are putting into our software development efforts, and we want to do less and get more out of the other side, then we want to use more automation. We want to use the computers for the things that computers are good at, and we want to reserve the stuff that we work on as human beings for the things that we are good at. So we're going to automate everything that can be automated. So that means automated testing, automated configuration management, automated deployment, automated monitoring, all of those things. And we're going to work on the things that we're good at. We're going to do the creative things. We're going to be focusing on the design and the evolution of our understanding of the problem and optimizing to be really effective at learning. And that's what we're going to try and achieve. A key idea in organizing all of this automation in continuous delivery is the idea of the deployment pipeline. The deployment pipeline is an idea that I and a few of my friends that were working on projects in the early 2000s came up with, and it's about building essentially a machine, a machine that's going to take commits in one end and generate releasable artifacts out of the other end. So the scope of a deployment pipeline is a genuinely releasable thing. The objective of the deployment pipeline is to prove that the change that we have just made is not fit to make it into production. And we're going to do that through a series of validation steps in the form mostly of automated tests. Now, at first sight, that might sound backwards. Saying that the job of the deployment pipeline is to reject our change, to stop us releasing change into production, sounds like it's the wrong way round, but it's not. That's one of these lessons that we can learn from science. However many automated tests or any other kind of tests I have, I can never ever prove that my software is good. But as soon as I have one automated test that fails, I know that my software is not good enough. Therefore, I can organize my work based on that principle. That has some implications for the nature of the tests that I'm going to build and the nature of the automation that I'm going to surround them with. It means that my tests need to be reliable. I need to, when I run a test, I need to get a definitive answer, and ideally I'm going to get the same answer every time for the same set of code. Flaky tests are problematic. I need to work hard to eliminate those, and intermittent tests similarly. We want to eliminate those from our build because we want to trust our tests. So we're going to put an awful lot of effort into building, creating and maintaining our tests that give us this great feedback. The next thing to think about when constructing a deployment pipeline is what things to test. What's the scope of our testing? And the simple answer is test everything. If we want to work experimentally, if we want to be more scientifically rigorous, if we want to be more like engineers in our approach, then what we need to do is that we need to take the feedback that we get, the evidence that we gather, seriously. So, what do we need to do when we're thinking in terms of a deployment pipeline? First, we're going to work and we're going to commit changes, and we want to be able to commit changes frequently. What we're looking for is that we're looking for fast, frequent, regular feedback. I generally advise my clients initially, in the initial stage of a deployment pipeline, to aim for feedback in under 5 minutes from the initial commit. We call this stage in a deployment pipeline the commit stage. And the objective of the commit stage is to give us fast failure. If we've made a mistake, we'd like to catch 80% of our mistakes at this point in the process and give feedback in under 5 minutes that's been achieved. That can be difficult to get that feedback at that kind of rate if you've got a large system or a complex system, but it's possible on surprisingly large scales. In the future, I'll do videos when I talk about some of those techniques and those ideas. But for the purpose of this, trust me, you can do this at enormous scale. So we're going to get fast feedback. That immediately starts to define some of the characteristics of the testing that we can afford to undertake in that time window. And the time is important. Again, I'll do another video on why the times matter in the future. The time window is important. So we're shooting for this short time cycle and 80% level of confidence. That says something about the kind of tests that we can run. These tests can't be slow. They can't be big and complicated. They need to be fast, efficient, and narrowly focused. We can't afford to start up our application, because starting up our application is going to be slow. It's going to slow down the testing. We can't afford to be talking to a disk system or a network or another process. These tests need to be intimately close to the software that they're testing. These are going to give us fast feedback and a tool that we can use to drive our development. If you've been paying attention, what I'm really describing here, ideally, is the fruits of test-driven development. That is the most effective way to get this kind of feedback, this kind of insight into the quality of our work. Test-driven development does some wonderful things. Again, more videos to come in this series that will cover that sort of stuff in detail. But test-driven development is a powerful tool. What it does, though, is test-driven development is developer-centered testing. What it does is it gives developers feedback that, yes, this is the code that I intended to write. The code is working the way that I expected it to. What it doesn't say is this the right thing? Does this work together with everything else completely? Does it deliver the value that our users want? For that, we need a different kind of testing. So the commit stage is focused primarily on this developer-centered testing. Is this change good enough? And does it do the things that I meant it to do as a developer when I created it? We need feedback from another dimension, and that dimension is best characterized as what a user wants of the system. Does this change deliver the behavior that the user intended? Is the software deployable? Is it configured correctly? Does it work with the database and the web server and the messaging system and whatever else is part of the system? And does it deliver the behavioral intent that the change was designed for? We need a different kind of testing. In continuous delivery, we talk about that as acceptance testing. This is user-centered testing, testing from the perspective of an external user of the system, evaluating the system in lifelike scenarios in a production-like test environment. We're going to automate the deployment and the configuration management of the environment so that we can reproduce that reliably and repeatedly. And then the automation will, when a successful commit comes through, having passed the commit stage, that will be promoted to the acceptance test stage. The acceptance test stage will run and will evaluate the change from the perspective of an external user of the system. And then there's a whole bunch of other tests that we can think of. Is the system secure? Are the security features of the system appropriate? Is the system scalable? Is it resilient? Is it fast enough? And we can kind of focus on those sorts of behaviours. If we have a user interface to our system, we can incorporate some level of manual testing, but the job of all manual testing is exploratory. We don't want any manual regression testing because human beings are too inefficient for that to work. We're going to use automation for all of that. So we're going to automate everything about the evaluation in that context. And human beings, as far as they are used to validate the system, are really just exploring the stuff. Does this paint pictures in my head that allow me to explore to the next point in the system? Does it make sense? Is it nice? Is it pleasant to use as a human being? Those are the kinds of answers that we're looking from that kind of exploratory manual testing at this point. If all of our tests have run, if all of them have delivered a message that says, as far as we can tell this works, then there's no more work to do. That is a defining characteristic of a continuous delivery deployment pipeline. If you built a deployment pipeline that just tests the development effort, it's not a deployment pipeline. If you've built a deployment pipeline that's just for deploying the system into your production system, it's not a deployment pipeline. A deployment pipeline goes from the initial commit of a change to a releasable outcome, a releasable artifact. It doesn't necessarily mean that we automatically push that release into production. That's a step beyond continuous delivery called continuous deployment. Continuous delivery is working so that our software is always in a releasable state. Continuous deployment is working so that if our deployment pipeline says the change is good, we'll push the change into production. That's a good thing and makes an awful lot of sense for some industries and probably doesn't make great sense for other industries. And so we distinguish between those two different things. In summary, continuous delivery is about the application of scientific rational thinking to solving problems in software. I think of this as a genuine engineering discipline if we take a strict definitional terms of what engineering means, as in the application of scientific rational thinking to solving practical problems within economic constraints, then continuous delivery qualifies along these lines. It's based on the ideas of optimizing for fast, efficient, high quality feedback. And it uses the ideas of lean thinking to reduce the amount of work that we put into the process while maximising the output, the outcomes that we gain from it. By working in smart ways, we can reduce the amount of drudgery around software development and only concentrate on the creative, important, essential aspects of our discipline. Thank you very much for watching. I hope you've enjoyed the video.